Hello, Nafisa and Matthew.
Hello, sir.
Hello, sir.
Hello. So today we'll discuss the telescope. Okay, we'll discuss telescope. So if you want to see the distant object like the moon, planets, stars, so there is a requirement of telescope. There is a requirement of telescope. So telescope, it helps us to see distant object like moon, planets, stars, etc. clearly. Okay, so telescope is helps us to see the distant object clearly. Okay, now we discussed the visual angle. I have discussed the visual angle, this alpha and beta. So I'm telling what is visual angle, because there is a requirement of visual angle here. This is the eye. Okay, here is this cornea and this is the retina. The back part is the retina. So if this is the object and this is the eye, so what angle this object is subtending on the eye will be the visual angle. So this is suppose the object and this is subtending some angle, okay, at eye. So this angle will be the visual angle, okay. And what is this? This is some object. And this is retina of the eye. Basically, retina is just like the screen on which the image is formed, and retina have light sensitive cells, rods and cones. When the image of the object forms on retina, these cells get activated and generate electrical signals, and those electrical signals are transferred through the optical nerves, okay, to the brain, and then brain interprets the image, and we are able to see the objects clearly. By the way, this is the retina. Large will be the large will be this angle. Okay, if I am talking about this angle is theta, then this angle will also be theta. Okay, and here will be the image, this will be the image, this will be the image. So large will be the visual angle, large will be the image. Okay, or you can write here more value of theta, bigger is image. Okay, so this is the visual angle is basically the angle suspended at eye by any object is the visual angle. Now we'll discuss the magnifying power of telescope. So the magnifying power of telescope is given by visual angle formed by final image that is beta, visual angle formed by the final image divided by the visual angle formed by object that is alpha. So this is the magnifying power of telescope. Now basically we have two types of telescope. One is refracting type telescope, another is reflecting type telescope. Okay, so more important is refracting type telescope, but there are certain limitations of refracting type telescope. We will discuss that also. Okay. In case of the microscope, compound microscope, you have one objective lens and you have one eyepiece lens. Here, objective lens was small in case of compound microscope, but the eyepiece lens is bigger as compared to the objective lens. Okay. So first we will discuss the refracting telescope. Refracting telescope. In case of the refracting telescope, there are also in this case also there are two lenses. One is objective lens another is the eyepiece lens. But in this case, the objective lens is very large. The objective lens is very large than the eyepiece lens. But eyepiece lens is also large. If you will compare the objective lens, then objective lens is very, very large. And the reason that the objective lens is very large because you are watching, you want to see the very distant object like moon. So from that distance, actually moon you can say at a distance of infinity, and from infinity the rays are coming. So objective lens is made bigger so that more amount of rays should strike on that. Okay, so that we will get a clear image of moon, planet, star, etc. Okay, so in this case also there are two lenses, and here objective lens objective is of large aperture, and large focal length, so that it can collect more light it can collect more light from distant object. Okay, now we will draw. So this is objective lens, and this is smaller eyepiece lens. Okay, and this is a telescope. Na? In telescope, this is the objective lens and this is the eyepiece lens. Here the objective lens is large, and why this objective lens is large? To collect more light from the distant object. Okay. This is the principal axis. Okay. This is objective lens. You can write. And this objective lens have large focal length. And what is this? This is eyepiece lens. This have small focal length. Now, the object that you want to see is at infinite distance, very large distance from you, moon, stars. And we know that when the object is at infinity, rays from that object are parallel. Rays from that object are parallel. Okay. Okay. So suppose parallel rays are coming, and this is the optical center. Okay. So parallel rays are coming, suppose like this. and another parallel ray, suppose like this. Okay, now after refraction, this ray will meet this ray like this somewhere here. Okay, so these are the parallel rays from the object. Parallel rays from the object at infinity, because the object that we want to see is at infinity. Okay, so two rays are there. I have only taken two rays. There are several rays, but we have just taken two rays. And after refraction from the lens, these two rays are meeting here, means here the image of that object is forming, and this image is diminished image and inverted also. So here the image is forming. And I told you, whenever the rays are parallel, image and those rays are passing from the convex lens or concave lens. Those rays will always meet at the focal plane. So image will form here at focal plane. Okay. So basically, this will be the focus of the objective lens. Okay. This point will be the focus of the objective lens, because these rays are parallel rays and passing through the objective lens. So here the image is forming. Now we can take eyepiece lens here. Okay. So this is the eyepiece lens, and this image is adjusted in such a way that this image is forming between the optical center of the eyepiece lens, and the focus of the eyepiece lens. Okay, here is the focus of eyepiece lens. Okay, this is the eyepiece lens. This image is forming between the optical center and the focus of the eyepiece lens. Now this image will behave as a virtual object for this eyepiece lens. Okay, this image will behave as a virtual object for this eyepiece lens, and this eyepiece lens will form the image of this virtual object somewhere. Okay, now this is a case. Now this is the object for this eyepiece lens, and this is the case when the object is placed between the optical center and the focus. So you will get a magnified and virtual image. You will get a magnified and virtual image. You can see here. See, whenever the object is whenever the object, this is the object between the optical center and the focus, then you are getting a magnified and virtual image. Same is the case here. Okay. This time, this is the virtual object and this is the object, you can say, and this is in between the optical center and the focus of the eyepiece lens. So for this object, the image will form. Okay, so we will draw the ray diagram again. So now this lens, eyepiece lens, will forming the image of this object. Basically, this is the image for this objective lens, but this image is object for the eyepiece lens. This is eyepiece lens. So first ray from the object, I am just uh, like this. Okay, first ray from this object is like this, and it will pass another ray is parallel to the principal axis. Another ray is parallel to the principal axis, and after passing from the lens, it will pass from the focus. So here will be the focus of the eyepiece, second focus of the eyepiece. So both these rays are diverging. Both these rays are diverging rays, and you will produce these rays in the backward direction and you will get the image. So when we will produce these rays in the backward direction, so we will get the image. Somewhere here you will get the image. Okay, and here the image will form. Suppose this is A dash B dash, and this is A double dash B double dash, and this is the final image. This is the final image. Okay, now understand what is happening here. Parallel rays are coming. This is the objective lens. After passing from the objective lens, the image is formed here. Okay, because these rays are parallel, so image is forming at focus of the objective lens. Now this image will work as virtual object for the eyepiece lens. So this eyepiece lens will form the image of this virtual object here. And you can see this image is larger in size. So basically you can say that this eyepiece lens is basically working as a simple microscope. This eyepiece lens is working as a simple microscope. Okay. So if you will take the distance, this distance will be the focal length of from here to here. This distance will be the focal length of objective lens, and this distance will be the object distance for the eyepiece lens. This distance will be the object distance for the eyepiece lens, because this is the virtual object for this eyepiece lens. Okay. Understanding, Nabal, Fisa, and Matthew?
Yes, sir.
Yes, sir.
Yes, sir.
Actually, what is happening in case of telescope, refracting telescope, we have two lenses. Here also we have two lenses. One is objective lens. Objective lens is bigger here. Now, why the objective lens is bigger? Because to collect more amount of light. Okay. Objective lens is of large aperture and large focal length, so that it can collect more light from the distant object. So to collect more light from distant object, this objective lens is made bigger, and this is the eyepiece lens of normal size. So now the object is distant object, means at a very large distance, at an infinite distance. So rays from that object will be parallel rays, and these parallel rays are coming like this and passing from the large objective lens. So this objective lens will form the image here, okay, of the distant object. The image will form here, and this image will be at the focal plane of the objective lens. This is the focus, okay, f naught of the objective lens, because parallel rays always meet at focus. So these parallel rays are meeting at the focal plane of the objective. Now, this image is in between the optical center of eyepiece and the focus of the eyepiece. Okay, so of this object, this eyepiece lens, this, okay, we will wait for 1 minute. Okay. So this image will work as a virtual object for this eyepiece lens, and this eyepiece lens will form the image of this virtual object here, and this is the final image. Okay, this is the final image of the distant object that you want to see. And this distance, basically the distance between the focus of the objective and the optical center, focal length of the objective lens, and this distance will be the object distance, okay, because the object is here with respect to this eyepiece lens. Now we will calculate the magnification. We will calculate the magnification. So magnification in case of telescope is this: visual angle formed by the final image divided by the visual angle formed by the object, beta by alpha. So object is at infinity, okay, object is at infinity. So alpha, what is alpha? Alpha is the visual angle formed by the object. So basically rays from the object are these rays. Basically you can say this is alpha. This angle will be alpha, angle alpha. If this angle is alpha, then you can say this angle will also alpha, vertically opposite angle. Now beta, you can take beta, visual angle formed by the final image. So final image is this is the final image. This is the final image. Now this image is subtending at angle of beta here. Okay, you can say this angle will be beta. This angle will be angle beta. So you have to find beta by alpha. Okay, visual angle formed by the final image divided by the visual angle formed by the object. So magnification you want to find, that will be beta by alpha. Now this A dash V dash image is very small. This A dash V dash image as compared to the object is very small. So alpha and beta will also be very small. Alpha and beta angles will be very small. So if alpha and beta are very small, then tan alpha can be written as alpha, tan beta can be written as beta. So first we will find tan alpha, then we will find tan beta. So tan alpha we can find from this triangle. See, this angle is alpha and this is the triangle. So in this triangle, tan alpha will be A dash B dash divided by FO, perpendicular, divided by base of the triangle. Base of the triangle is this distance. So you can find tan alpha. That is equal to A dash B dash, A dash B dash divided by FO. And tan alpha, you can write alpha. So you will have alpha is equal to A dash B dash divided by FO. This is your equation number 1. Now for beta, see this triangle. This triangle. From here you can find tan beta. So tan beta will be A dash B dash divided by UE. Okay, because tan beta is perpendicular divided by base, and base is UE and perpendicular is A dash B dash. And tan beta you can write as beta because alpha and beta are very small. So you will have beta is equal to A dash B dash divided by UE. UE is the object distance for the eyepiece lens. Now find magnification beta by alpha. Beta is A dash B dash divided by UE, and alpha is this A dash B dash divided by FO. A dash B dash divided by FO. So the magnification, you will get this A dash B dash will be cancelled out. So you will have FO divided by UE. This will be the magnification of the telescope. Okay, take the screenshots.
Done.
Done. Okay.
Yes, sir. Done.
Done. Okay. Okay. So magnification of the telescope is focal length of the objective length divided by the object distance for the eyepiece. Now remember what is the object distance for the eyepiece, because this is the image that is forming by the objective lens, and this image will work as a virtual object or object for the eyepiece lens. For this object, for eyepiece lens, the image will form here, and this will be the final image. Now two cases will be there: maximum magnification. So remember this formula of magnification, f naught by ue for the telescope. Now case number 1. Case number 1, maximum magnification. If you want the maximum magnification, then case number 1. In case of the maximum magnification, the final image should form at least distance of distinct vision, that is 25 centimeter. In the last classes, I told you what is D. So final image by eyepiece, because you can see here the final image is forming by eyepiece lens. That is why I am writing final image by eyepiece at D. Okay, and what is D? That is equal to 25 centimeter. Can be of negative also. So you can say that this is a condition. This image is at a distance of 25 centimeter from this eyepiece lens. Okay. So in this case, the final image is forming at a distance of D. So this distance, this is the final image. So this distance, you have to take D. This distance, you have to take D. And this distance will be taken as negative because you will measure the distance from the eyepiece lens. Because final image is formed by the eyepiece lens. So you will consider eyepiece lens and you will measure the distance from the eyepiece lens. Incident ray direction is in this direction. Okay, you can see the direction of the incident ray is this. And for measuring the image distance, you are moving in this direction. So you will take V is equal to minus D. And object distance for the eyepiece lens is this UE. And for measuring this UE, you have to move in this direction. From the pole, you will measure the distance. From the optical center, you will measure the distance. So you will move in this direction. If you will move in this direction, that's this, you are moving in the opposite direction of the incident light. Then UE you will take negative, minus UE. And focal length will be the focal length of eyepiece lens. Now you can apply this formula, 1 upon V minus 1 upon U is equal to 1 upon F. So it will be 1 upon minus D minus 1 upon minus UE is equal to 1 upon FE. So it will be, this will be 1 upon this minus and minus will be plus, it will be 1 upon UE, and this 1 upon minus D will go this side, it will become plus 1 by D. So it will be 1 upon UE is equal to 1 upon FE plus 1 by D. So you have the value of 1 upon UE. Now you can find the magnification in this case, that is focal length of objective divided by UE. So 1 upon UE you have this value. So you can find the magnification. 1 upon UE, you will have 1 upon FE plus 1 by D. So you can take common FE. Okay, you can take common FE from this. This is F naught. And if you will take common FE from this side, it will be FE here. And here there will be only 1 plus. Here you will have FE and divided by D. So this will be the final magnification, maximum magnification. If you want maximum magnification, then Okay. Case number second. Normal adjustment. If you want the maximum magnification, then image will form at 25 centimeters. So to see that image, your eyes will be in strained condition. Case number second, normal adjustment. In case of normal adjustment, the image will form at infinity and we can see easily. So there will be no strain in eye, relaxed eye. Relaxed eyes condition. So in this case, the final image will be at infinity. Infinity. So final image is at infinity means this is was the final image and this final image is now at infinity means V is equal to, for the eyepiece, because eyepiece is forming the final image, the image will be at infinity, so V is equal to infinity. V is equal to infinity and the object distance will be the same, UE. Object distance will be UE and you will take this negative because you are measuring this UE in the opposite direction of the incident light. So the object distance will be minus UE and focal length will remain same for the focal length of eyepiece. You can apply this 1 upon V minus 1 upon U is equal to 1 upon F. So it will be 1 upon infinity minus 1 upon minus UE is equal to 1 upon Fe. Now 1 upon infinity I told you is 0. 1 upon infinity is equal to 0. So this will be 0 and this will be minus minus plus. It will be 1 upon UE. You will get 1 upon Fe. Now you can find the magnification. Magnification is of telescope is focal length of objective divided by UE. So you have 1 upon UE as 1 upon Fe. So the magnification in this case will be FO divided by Fe. So this is the minimum magnification. This is the maximum magnification. And what is maximum magnification? FO by Fe 1 plus Fe by D. Okay. If this is the condition, uh, if this is the condition and someone is asking length of telescope, that is L. So in this case, the length of telescope will be this, the distance between the objective length and eyepiece length, that is FO plus UE. FO plus UE. You can write in terms of mod. Now in this case, if someone is asking the length of telescope, then it will be FO upon UE. But in this case, what is UE? From here, you can find UE. UE you will have FE. So length of telescope in this case will be FO plus FE. I'm writing in terms of mod because length can never be negative. Focal length can be negative, but length can never be negative. Okay, write down. Done.
Yes, sir.
Okay, okay. So now see the summary, what we have done. So what is the magnification? The telescope, that was focal length of objective lens divided by UE. Okay. Now this was the magnification for the telescope. Now for the maximum magnification, we have two cases. One is the case of the maximum magnification. Maximum magnification. And what is the maximum magnification you have? Okay, first tell me what is the condition for the maximum magnification. Image by eyepiece lens should be at D. At D. And finally, you will get the maximum magnification as FO by FE 1 plus FE divided by D. And what is the length of telescope in this case? FO plus UE. In case of the normal adjustment, where should the image form? Final image should be at infinity. Final image at infinity. And what magnification you have? FO by FE only. And what is the length of telescope in this case? FO plus FE. So take the screenshot of summary. Then we will solve numerical. Okay. Now we'll solve numerical. For numerical, you should know this summary. Okay. What is the magnification in case of the normal adjustment? What is the magnification? What is the maximum magnification? Okay. So you should know the formulas. FO is the focal length of objective lens. FE is the focal length of eyepiece lens. L is the length of telescope. UE is the object distance for eyepiece lens. D is the least distance of distinct vision, that is 25 centimeter. A refracting type telescope a refracting telescope is under normal adjustment. And magnifying power is 5, and its magnifying power is 5. Magnifying power is, or you can write is magnification is 5. Okay, so you can write magnifying power also. Magnifying power is 5. That also means the magnification is 5. If the length of telescope under this condition, if the length of telescope under this condition okay, when final image is at infinity, means for the normal adjustment we know the final image is formed at infinity. Okay, normal adjustment, final image is formed at infinity. So it is given in the question, when final image at infinity. So if the length of telescope under this condition is 150 centimeter, find FO means focal length of objective lens, and Fe, focal length of eyepiece lens. Good. Very easy question. So this is a refracting telescope that we discussed. This is under normal adjustment. Normal adjustment is this. Final image is at infinity. So it is given that magnifying power means magnification is given. 5. What is the magnification in case of normal adjustment? FO by FE. So FO by FE is given. That is equal to 5. From here you can find FO is equal to 5 times of FE. Question number 1. Now what is given? Length of telescope is given. What is the length of telescope in case of the normal adjustment? FO plus FE. You can remove mod now. So length of telescope is 150 centimeter given. So what is the length of telescope in case of the normal adjustment? That is FO plus FE. FO plus FE, and that is equal to 150 centimeter. (150 centimeter). Okay, now you have two equations. Question number 1, question number 2. Solve equation 1 and equation 2. So this put the value of FO here. So what is FO? 5 times of FE. So FO is 5 times of FE from equation 1 and 2. From equation 1 and 2, put the value of FO. FO is 5 times of FE. Okay, so put here 5 times of FE plus FE, that is equal to 150 centimeter. So it is 6 times of 6 FE is equal to 150. So FE you will get 150 by 6. Okay. So cancel this. 3 to the 6, 50, and you will get 25 centimeter. So focal length of eyepiece is 25 centimeter. Now FE you have, from this equation you can get FO. Okay, so you have FO is equal to 5 times of FE. So 5 times of FE is 25. So 25 5s are 125. So FO you will get 125 centimeter. So this is FE. This is FO. What is FE and FO? FE is the focal length of eyepiece. You can write here. FE, focal length of eyepiece length. What is FO? Focal length of objective length. Objective length. Okay, take the screenshot. You already have this summary. And L is the length of telescope. Just a minute. Write what is L. Okay. Now take the screenshot. Done?
Yes,
Understanding, Matthew
yes,
and
sir.
Nawal and Nafisa. You have to only
Yes, sir.
use these formulas,
Yes, sir.
okay? And you have to read the question properly. In this question, there is nothing. It is given magnifying power is 5. Means magnification 5 is given. And this is given also normal adjustment. Now you can see here for the normal adjustment, what is the magnification? That is FO by FE. So put FO by FE. Little bit effort you have to do. I am not saying okay, you have to do little bit effort, but it is not hard. So FO by FE you will write. You will get one equation from here because you are in 12th class now. Equations you can solve, I think. Okay, so after that, another equation you will get from length of the telescope. I told you length of telescope in case of the normal adjustment is this. So you will get length of telescope, this FO plus FE, and this value is given as 150. In this question, there is nothing complex. One more question we will solve. Focal length of objective length of refracting telescope. Now try to focus on the question. Okay. Focal length of objective lens of refracting telescope is 100 centimeter and that of eyepiece is 5 centimeter. You can see here objective lens is this much bigger than this, 20 times bigger than the eyepiece lens. If the final image is formed at D, means at least distance of distinct vision, find magnifying power find magnifying power and length of telescope. Okay, now see. Focal length, what things are given in the question? First write down. Focal length of the objective lens is 100 centimeter, means focal length of the objective lens is 100 centimeter given. And focal length of eyepiece lens is also given. That is 5 centimeter. Okay. If the final image is formed at the least distance of the distinct vision, means final image is forming at D. Now you can see here the condition I told you. If the final image is forming at D, what is that condition? If the final image is forming at D, then it is a case of the maximum magnification. Okay. So in this case, the final image is formed at least distance of distinct vision, means at D. The final image is forming at D. Find magnifying power. Now, in case of the maximum magnification, what is the magnifying power? FO by FE 1 plus FE by D. This formula. FO by FE 1 plus FE by D. This is the magnifying power in case of the maximum magnification or image is forming at D. Okay, FO by FE 1 plus FE by D. Okay, so what is FO? 100. What is FE? 5. This is 1. What is FE? 5. What is D? We know D is 25 centimeter. So from here, what you will get? This will be 5, will be 20, and it will be 5 5 is 20, so it will become 6 by 5. So magnifying power you will get 24. Okay. When you will cancel this 20, 5 4s are 20 and 6 4s are 24. After that, you have to find the length of the telescope. So in case in case of the maximum magnification, the length of the telescope is this FO plus UE. Okay. Length of the telescope is FO plus UE. You have FO, but you do not have UE. So how you will find? See, final image is forming at D. Final image is forming at D means V you will take minus D. You will take this as minus 25 centimeter. And U you want to find means UE. you want to find? It will be basically minus UE. Focal length of eye lens is given as 5 centimeter. So you can apply this relation 1 upon V minus 1 upon U is equal to 1 upon F. So 1 upon V is, it will be minus 1 upon minus 25. Okay, it will be 1 upon minus 25 minus 1 upon UE. It will be minus UE, okay. This is equal to 1 by F. It will be 1 by 5. So from here, you will get 1 upon UE is equal to 1 upon 5 plus 1 upon 25. So 25 you can take LCM. 5 5s are 25. It will be 1. So you will have UE here. That is 25 by 6. And 25 by 6 is 4.166 centimeter. So UE you will have this. Now you can find the length of the telescope. That will be FO plus UE. So FO is given as 100 and UE you will have 4.166. So it will be 104.166 centimeter will be the length of telescope. Now, how I have done this? We know that this is a normal adjustment. Oh, this is the case when the image is forming at a distance 25 centimeters. That is why image distance, and we know that the final image is formed by the eyepiece length. So with respect to the eyepiece length, the image distance will be taken as negative. Okay, you should go through the diagram for that. Many times we have done that. Here you can see final image is at D. We have taken minus D, that is, and D is 25 centimeter. And U we have taken this. We have only applied this. Basically, we will get this. You can learn this also if you want. For the case of the maximum magnification, 1 upon U is equal to 1 upon Fe plus 1 upon D. So I will not recommend to learn that. So this we have done, and finally we get UE. And what is the length of the telescope in case of this? In maximum magnification, F0 plus UE. So F0 we have 100 and UE we have 4.166. So it will be 104.166 centimeter. So you have to focus here. Okay, revise the notes again if you are not understanding how this is D. I told you that in case of the telescope, when we were discussing the telescope, this is the eyepiece length, and final image is formed by the eyepiece length. So with respect to the eyepiece length, if the final image is forming at D, so this D distance you will take negative. Why? Because you are measuring the distance from the eyepiece length in this direction, and the direction of the incident light is in this direction. That is why D is negative, and UE will also negative for the same reason. Wait, Matthew, you have you taken the screenshot of this question?
Yes, sir, I already did.
Okay, so please take the screenshot of this question and try to understand the things.
Done.
All of you complete this?
Yes, sir.
Okay, so basically this chapter is finished. There is one topic left, and after that I will start the modern physics, and for the wave optics I will take separate classes. Okay, but in continuation of this batch, we will start first. We will finish the modern physics. Wave optics part we will complete. Okay, uh, I will take for that your extra classes. Okay, otherwise the syllabus will not be completed on time. We have very limited time, so
Okay.
uh, so wave optics we will complete for in extra classes, and modern physics is very easy, and that can be finished easily. This part, the ray optics is most difficult part. The modern physics we can complete easily, and the wave optics we will do in the extra classes. I will tell you the timing of the extra classes according
Okay,
to
sir.
your timing, and then only we can finish the syllabus on time. Otherwise, there will be problem for you or for me also. Okay, so we will meet in the next class now. Okay.
Thank you, sir.
Okay,
Okay,
sir.
fine.
Thank you.